Welcome to the Christmas Eve edition of Forecast Lab. Clear skies here. I don't know if you would call this Christmas-like, but it is brisk. And of course, it's a bit of a difficult time for a lot of people. And we heard the bad news from this morning: Congress, political fighting, and unable to approve the stimulus package. And right now, we've got 4 members in our extended family with COVID. So we have a lot on our minds here. How about you all? No need to worry about me. We've been avoiding all contact since March. And since that virus seems to be suddenly appearing on our radar everywhere, I want to urge you all to take precautions and be careful out there. I've been trying to avoid that subject for quite a few months here, but I think it's time to make an exception. Anyway, the bad news out of the way, it is Christmas. Let's check out the weather. We've got a weather system there in the Atlantic, and you might remember the surface analysis yesterday. We had kind of a warm front feature down in Georgia that has lifted north, and that's dividing these near 70s temperatures from much cooler conditions to the north, and that pretty much makes this its own weather system. I did see a thermal contrast between Ohio and Pennsylvania, so I did keep a front there. Anyway, weather is going downhill. We can see snow from Columbus out to Pittsburgh and all the way up towards Cleveland and Erie, where we have some freezing rain being reported. Cold conditions coming down from that snowpack, where we've had that blizzard yesterday. Single digits and teens across much of the Midwest. And as you go south, you can see that the air mass does get quite a bit warmer with 50s in Texas. And if you go further west, very strong downslope from Alberta down to Wyoming with 40s and 50s showing up in the weather data. Plateau high is entrenched across the Great Basin area. That means a very dry air mass, very cold overnight conditions, and cool daytime temperatures. And this pattern favors radiational fog, very persistent cloud layers in the valleys and sheltered areas. And that tends to break up only when we get a very strong westerly flow off the Pacific. So let's take a look up in Canada. We're always wanting to check that out. Let's go all the way up there. We can see we've still got that Arctic air mass. I prefer to outline those minus 30s. And they run about like that. So pretty much in the high Arctic, near where the former dew line was, DEW, distant early warning. And the coldest temperatures I'm finding, minus 37, on Banks Island. We do see some of that cold air is starting to move south. Temperatures have cooled down a little bit in Yukon. However, to the south of that boundary, very warm conditions, 37 up there in northwestern Alberta. Now, of course, we want to keep some of our technical focus, and what I want to do is drop a couple of skew-ts in this air mass right here. This is obviously prime Arctic air sitting over the Canadian high Arctic. What do those soundings look like? Now, often I like to look at the forecast soundings, but in this case, the Arctic air is going to be kind of delicate and very shallow and have very fine-grained details. So I'm going to look at actual soundings using the University of Wyoming website. So we're going to click on Resolute Bay up there. That's going to be this station right here where it's minus 20, and minus 30 is not too far away. So picture in your mind, what do you think it's going to look like? Are we going to have very deep, very cold air, or is it going to be kind of shallow? And the answer is it's kind of shallow. This is a characteristic attribute of Arctic air. It's a little bit different from polar air. Polar air tends to cover much of the northern latitudes. Arctic air is an even colder variation of that, and it tends to be shallow and maintained by strong radiational cooling. You can see that it tops out at about 1 kilometer. Below that, temperatures fall from minus 25 to minus 35 Celsius. And above that, we can see that the temperatures are a little bit more normal, and there's a northwest wind at 20 blowing through there. The tropopause is still kind of high up at about 31,000 feet. Let's try another sounding, Cambridge Bay. Very similar pattern there. You can see the very sharp drop-off. That's a very strong inversion. And the Arctic air tops out either there or maybe a little higher. Maybe that's a secondary layer of Arctic air. But you can see above that, if we bring that air down to the surface, somewhere in between the dry and moist lapse rate, we only get about minus 10 Celsius. That's about 14 Fahrenheit. So this is not very cold air aloft. And that shows you the distinction between the shallow Arctic air and the elevated polar air mass layer. I did some Googling around for air masses, and I found this webpage for Steve Ackerman at University of Wisconsin, and it's got a good chapter here on air masses and fronts. So if you put that in a search engine, you'll probably bring this up too. But yeah, there it is. The Arctic air mass formed over the frozen Arctic and much colder than continental polar air, confined to a shallow layer near the surface. It's typically less than a mile deep, not much vertical lifting and little precip, but occasionally it moves into the southern U.S. Now, often Arctic air is used as a catch-all by some weather forecasters, TV weather meteorologists, and so on, but true Arctic air rarely reaches the U.S. Now, that so-called polar vortex storm from 2014, yeah, that was Arctic air coming into the Midwest. But we don't have any of that across the U.S. This is all polar air. And those temperatures are cold, but they're not unusual. Elsewhere, we do have some thunderstorms on the Atlantic coast. Enhanced risk with a tornado watch box out for North Carolina and far eastern South Carolina. Let's check that out. We always want to start by looking at the radar because that tells us what convective mode we're in. Simply by looking at the aerial extent of the convection, we get an idea how strong the boundaries are, how strong the capping is, if there's any capping, and so on. And of course, the intensities. If there's any very strong cells in there, that tells us that there's a lot of CAPE. So a lot to be seen here. And what we see here is this is a very uncapped air mass with numerous cells. We can't rule out severe weather, though, but I don't really see any bow echoes. Maybe a couple of transitory features that might be of concern. Let's see, that's going to be up in this area here. Looked like there was something going through there that had bow characteristics. Let's see, it's going to be, yeah, right there. See how those were kind of isolated, and they were intense also and had kind of a convex shape. So it appears there is a little bit of severe weather going on here and there. Let's take a look up in Norfolk, because I did see some higher intensities there on the SPC map. Doesn't look that much stronger on here, so that might be just kind of an artifact from the composite reflectivity that they're using. But certainly some intense cells up there, and those extend all the way to the Washington, D.C. area. And let's go down to the tail end of the line. And this will be the Wilmington radar. And looks like more of the same. And a lot of activity offshore that's likely associated with the warm air advection, not so much with the heating and deep convection going on further west. So the tail end, that's near the Wilmington area, and that can also have some localized severe weather potential as it moves northeast. Now, we can't spend too much time on this situation, but for a very quick look, we can look at the theta E product. And that gives us an idea of the total thermodynamic energy available from parcels going into the circulation here. So let's see, stronger theta E's down to the south. That means higher temperatures and especially higher dew points. And this little tongue here coming up into North Carolina, this has the most potential to interact with the upper level thermal profile and extract the greatest CAPE. And let's just go forward in time and see how that evolves. Yeah, you can see the outflow kind of gusting in here. That's outflow kind of distorting the field from the model generated storms. So kind of a ripe environment out ahead of these cells. And we can drop a parcel in these unaffected areas. In fact, let me drop it inside the storm. See this right here? Lower theta E's. That's going to be a cold pool. I'm going to show you what a sounding looks like in one of those. This will be a contaminated sounding. So for one, we see very high omegas. We also see kind of a straight moist adiabatic lapse rate. Those would be some indicators that you're inside the cell, so you want to back off and get out ahead of it, out in this region. And we're going to see the profiles to be a little bit different. Now this looks like it's inside some clouds, so I'm going to keep moving around. Yeah, so this along the coast, this looks to be a little bit more representative of the air mass out ahead of these cells. And what we see here is quite a bit of shear. However, it is straight line shear. We see that the cell motion is very rapid, 60 knots there, and we're squeaking out just a little bit of SRH, enough to bring it up to the 200 range. Now, one problem is there's not very much instability. That lapse rate there is almost moist adiabatic. And it looks like the moisture is a little bit on the shallow side, only about 1 kilometer deep. I mean, that's enough to generate severe weather, but, you know, there is dry air just above that can be entrained into the updrafts. So consequently, the mixed layer CAPE running about 1,000, which is marginal. However, it looks like there's just enough parameters here, specifically with the shear, to drive the hazard algorithm up into the tornado range. So based on this, I wouldn't expect widespread tornadoes or anything like that, but there could be a chance of brief tornadoes wherever those cells can manage to spin up. So this is a case for watching the radar closely and looking for potential storms like the one you saw in the animation earlier. And as far as yesterday's storm, this is the snow depth product as of midnight this morning. Looks like on average up to 10 inches in the Minneapolis-Duluth area, and maybe some patches of 10 inches southwest of Sioux Falls. And there's some of the official totals: 9 inches there at Maple Grove, 8.8 at Minneapolis, and 6 to 7 inches around the suburbs of Minneapolis, and 5 in Duluth. Let's look at the 24-hour snowfall. Oh, do you see that right there in Lake Erie, Lake Ontario, some lake effect snow being indicated by the GFS on the 26th. Looks like an Alberta Clipper coming through Minnesota, and then our Great Plains system gets going. These are 24-hour accumulated snowfalls using the 10-to-1 ratio, so that may not necessarily be accurate. So it's going for 15 to 20 inches still, but we're quite a ways off. 120, 140 hours out. We'll probably want to wait till the weekend or early next week to nail down those numbers. And I think that'll do it for our Christmas Eve broadcast. I appreciate you watching, and hope you all have a great Christmas, or whatever you want to call it if you don't celebrate Christmas. Now, I was planning on doing a video tomorrow on Christmas. I'm getting a little bit of pushback from the family. You know, of course, you want to spend time with family. So we're going to play it by ear. If I happen to have some spare hours where I can do a video, we'll put it out. It might also be short. But if not, we'll see you sometime during the weekend or on Monday. All right. Have a great one. Take care. Bye-bye.